Hi, I'm Amanda Flink, and I am pleased to lead our discussion here today. 5G is here with multi-gigabit speeds and ultra-low latency, ready to open opportunities for the Internet of Things. While 5G brings more versatility and capabilities, the technology is more complex and presents design challenges for OEMs. Today, we will discuss the technical side of 5G and examine 5G technology for various use cases across verticals and the design considerations. So who do I have with me here today? I am joined by Jeff Clemo, our VP of Strategic and Channel Sales. Hey, Jeff.
Hey, Amanda.
And we've got Tim Hadley, the Senior Field Application Engineer. Hi, Tim. Thanks for joining.
Hi there.
Awesome. So you guys ready to dive in?
Ready to go.
Yeah. All right. So can we set the stage for everyone here by explaining sort of the technical side of 5G? Things like what are the key differences between millimeter wave, sub-6, red cap, some of these buzzwords that we hear, right? Let's just spend a little time discussing this.
Okay. Well, that is like the open-ended question of the day. So, yeah, I think 5G at a real high level is a transformational technology from our current 4G LTE on the cellular side. And the dream is to ultimately replace all the different categories of LTE. But we're not there yet. There's going to be evolutionary steps. And the industry first started with the real high end, the gigabit downlink and uplink with carrier aggregation. And what we found is most of the OEMs that have been playing with 5G so far have learned the hard way that you can't just put it into an existing LTE design. And if you're doing a brand new design, you really got to step up your game because so much of the needs are to be with current standards on the kernels, and so your CPU and your MCU and your bus and everything just have to be as current as possible, both from a hardware and software perspective. And Tim, you live and breathe this every day, so
yeah, we see a lot of manufacturers trying to use their existing designs and try to kind of fit 5G into that mold. There are a lot of similarities between 5G and LTE. As the biggest differences are really on the physical layer. The more you move up the stack, the more similarities that you find between 5G and LTE. But ultimately, for 5G to do the job that it's going to do, like Jeff was alluding to, you have to make sure that you start with a fresh design. You have to make sure that you have the power supplies that are capable. You have to make sure that your antenna system is capable. You also have to make sure that your data bus is capable. At some point, you're no longer be able to use USB because it's not going to support the speed and the throughput that you get over the air. So you may have to switch to PCIe. So for all those things, your internal hosts, you need to be using the latest kernel versions. So there's a lot of things to consider with the newer 5G design.
Yeah, and Amanda, that's definitely, today where we're at because of the initial modules that were, put into the marketplace. But now we're getting ready to do the next generation of that, and nothing's really changed, right? The focus still is on the very high end. So for the newer modules coming out in early 2023, we're going to really have to continue this mantra of you've got to start from a new design or substantially overhaul your LTE design, because so far, as Tim pointed out, we've seen so many customers try to just shoehorn it in. While it's an M.2 connector and it may fit on the board, that doesn't mean it's going to work. And, many times you might even get it to start up and run and attach to the network, but then when you start doing actual field use of your end device, you start to see, performance not meet the standards that you want, or you're going to really start having issues with timeouts and data corruption and things like that. So that there's a ton of things to consider. Now, you mentioned where's 5G going with things like RedCap. As I said at the beginning, the dream is to eventually have 5G replace all the current LTE designs. So the next step we're going to see in 2023 is the LTE high-cat products that are out there in the marketplace will start to get cannibalized by this newer 5G chipsets because the price points come down. The performance really isn't changing a whole lot. I mean, we're adding SA mode natively to the new, that's standalone mode versus, non-standalone mode, which requires an LTE base. But you're looking at, with the new chipsets, a lower price point. So we're assuming that'll both help existing designs maybe move on to the newest and latest and greatest, but it's also going to bring in a lot of new players that have not done 5G yet. So again, Tim lives this every day, day in and day out, and there's not a lot of difference between the new chipsets other than, I don't know, Tim, maybe you can explain.
Well, one of the things that we'll have to look out for, and LTE's got a lifespan, a projected lifespan of about 10 years of what I hear people saying. But what's going to happen is they have to make room for spectrum allocation for 5G. And so what's going to happen, they're going to have to take those existing 4G bands and move them over to 5G. So your Cat 18 LTE module that's working fine for you today, 3 or 4 years down the road, may not be able to get the same speed simply because the spectrum is not going to be available.
Right.
And they're going to be reallocating that to 5G. So that's one of the reasons it's kind of important to move that way. And like Jeff was saying, RedCap is kind of aimed, I guess, to be an LTE replacement, if you will. RedCap stands for reduced capability, and so it'll still allow for the modules that don't really require the high speed and high throughputs, but they'll still operate on the 5G system, which eventually the whole core network is going to be going in that direction.
Yeah, I think to pick up on the RedCap topic, the initial chipset and modules that'll come out supporting Release 17 and RedCap, so that's the 3GPP standards, Release 17, that's going to be targeted just at the Cat 4 marketplace. So if you take an LTE Cat 4, they're going to take basically and throttle down the chipsets and so that the modules are basically performing at a Cat 4 level. So what'll happen is there'll be a gap between Cat 4 and the low end of the new 5G modules that we're seeing today. So obviously market adoption and timing will drive where the pricing in the market goes and how fast all this takes place. But Cat 4 is where you've got a little better performance, but your uplink really, and in 5G your uplink will be better too. So you're going to have maybe a higher performing Cat 4 with 5G. And of course, with that will come probably a premium cost to develop, but it'll be more like LTE from a design standpoint. So it'll be not nearly as complex because you won't have the carrier aggregation and all the things that you need to overhaul your bus on. But that doesn't mean your LTE design can stay from 5 years ago. When you do RedCap 3-4 years down the road, it'll be pretty much the same mantra. You're going to have more current hosts and drivers and such. And I don't know, it's still really early, so we'll have to dive into that, over the next couple of years as that standard rolls out into the chipsets and we actually start building products around it.
Yeah. So when we talk RedCap, are we talking 2024, 2025, even further than that? What's sort of our timeline here?
Yeah, so the new generation of 5G modules, like I said, are actually going to be going into mass production, mid to late Q1, early Q2 of 2023. The RedCap standard, which is Release 17, will be done sometime next year, and then there'll be usually a 12 to 18 month cycle after that. Now, we're expecting by the end of next year to have some engineering samples of the chipsets and be starting to do our design development. But it'll probably be late 2024 before any commercialized RedCap products are available. And again, like I said, they're going to be priced higher than the LTE Cat 4. So it's going to be one of those things where I think the early adopters will be based on their use case and their needs for the uplink side. And then they'll, their products probably aren't as cost sensitive. Anything that is going to be really cost sensitive and only need up to Cat 4 technology will be able to continue on LTE, as Tim said, probably through early 2030s. The gap is when you get into the high Cat LTE, the Cat 12, 13, 18, up to 5G. That gap is going to try to be filled by the low end of 5G. So it'll be interesting because there's a price delta there. And but if you look at where the networks are going, even though they're not necessarily end-of-lifing LTE, they're in essence, by cannibalizing the LTE spectrum for 5G, end-of-lifing the high-cat. It's kind of a weird thing. It won't be an official network shutdown or anything like that. It'll be a subtle, wow, this product doesn't work as advertised. It still works.
Yeah.
Still works. But, I mean, maybe you can just give them a briefing on the carrier aggregation and its impact. Tim.
Yeah, what'll happen, like I kind of alluded to earlier, is that as they start clearing spectrum and they start making more spectrum for 5G, you're going to see some of the bands for 4G begin to disappear. And that's where Jeff was saying on your high-cat modules, your Cat 12s, your Cat 18s, while LTE won't necessarily be sunsetting or be gone, the capacity and the performance of LTE is going to kind of slowly be reduced in order to make room for 5G. And current adopters of 5G, I've heard a lot of customers initially were pretty disappointed with the performance that they're getting from it. And that, again, is just due to spectrum allocation. So right now, the spectrum that's allocated for 5G, the bandwidths, you're only seeing maybe 5, at the most 10 megahertz bands for 5G. And most of your uplink and downlink, you're maybe seeing 1, maybe max 2 CA for uplink and maybe 2 CA for downlink. So still, most of the burden is being put on LTE as far as throughput and performance goes. And so that's kind of the trend that we're seeing. And again, the early adopters are saying, well, you know, my phone says 5G on it, but it works better in 4G LTE. And that's just kind of a reality of the system and the way it develops and rolls out, similar to the way the LTE did when we were switching from 3G to LTE. You know, initially people didn't see the performance gains that they thought they're going to see in 4G. And after it matures, after do the spectrum clearing, and the performances will start to come up, especially when we start getting into standalone mode. And we can start to aggregate more carriers and use the spectrum more efficiently.
Yeah. Yeah, standalone mode is going to be another decision-making point as to whether you go to 5G or not, because we said non-standalone is where you have the LTE network as kind of your starting point, and then it brings, so you're attaching to the 4G LTE, then it moves over to 5G. Standalone is just pure 5G, up and down. But I think coverage will be the big limitation there, as you see big metropolitan areas where they're moving quicker than maybe rural areas. There'll be kind of a lag effect. But that also brings up the millimeter wave part of 5G. You know, we've talked about the high end, we've talked about the coming of RedCap and all that, but millimeter wave, which initially was really promoted as a starting point for 5G, is really panning out to be kind of a bust. And that is because of the complexities and the cost of millimeter wave. You have not just the module cost, but you also have the antenna cost. And the antenna costs basically double your total cost of ownership for deploying. So with millimeter wave being line of sight, even though there is a mobile functionality within it, it's still line of sight. Your design is very sophisticated from an antenna perspective, and your cost is double. So you have very specific use cases that makes sense for, and we've just in general seen a very small adoption of millimeter wave, primarily for private networks where they have a lot more control over their environment. But for the commercial networks, everything has gone what we call 5G sub-6, right, which is where most of the spectrum holding is for like T-Mobile and now Verizon. AT&T's not carved out much yet for that. They all own a lot of millimeter wave, so they're going to have to figure it out sooner or later. But I think the business model right now has got that much farther out in the future than what we've seen so far. Would you agree, Tim?
I would agree. Yeah, I've seen the deployment and the uptick on millimeter wave has been much slower than we initially anticipated. Development from 4G to 5G for FR1 is a lot more simple. You can basically use the same antennas for 5G FR1 as you do for LTE. So that lowers the cost of development. Also, the power requirements, the mobility aspect, a lot of the workings are pretty much the same. When you get into millimeter wave, it's completely different. As Jeff was saying, it's line of sight. We're up on microwave frequencies now. The antennas are receivers and transmitters in and of themselves. And because of that, it's going to require specific certification, which is also going to up your cost. That's setting aside the material cost as well. Okay, certification is going to be another problem, especially if you have a device that supports both FR1 and FR2, and you'll have to certify for both of those. And there are handsets that do use FR2 and millimeter wave, and the performance is good. I've seen some testing done on there, and we're getting throughput speeds into the 2.5 and maybe sometimes 3 gigahertz ranges in ideal environments. And what's going to happen eventually when millimeter wave matures, you're going to be able to overtake the throughput that you can get on a standard wireline service. And I think that's the future, and that's what they want to go to. But at this point right now, it's not quite mature enough yet, and the use cases aren't really there yet for millimeter wave because, like you said, Jeff, it's more designed for CPE use and high throughput rather than it is for mobility. And like Jeff also said, the complexities are very high, and the equipment costs are high as well. And so I worked with a couple of companies that were trying to develop this for private network and also for MNOs, and a lot of them had kind of just quietly abandoned the project just simply because of the cost and the complexity and the amount of time it's going to take to develop something like this.
Yeah. You guys have talked a lot about different technologies here. So, why would somebody choose 5G versus LTE?
Well, there's usually a couple of key drivers. The first is they just need the performance. So your uplink on 5G is better. So if you have a very uplink-centric environment, like say video or high definition imaging, or you have a lot of throughput that you need to support on the uplink, so from the end device back to the network, then 5G by far is going to be superior and will continue to be so. I think the other big thing, and we're seeing it in a lot of industries that really don't change their end devices out in the field very often. They have a very long life cycle. What you're seeing there is the future-proofing concept, right? So, okay, I know it's not all here today, and I'm kind of paying a premium, but I'm locking in for when I don't have to make a replacement 5, 6, 7 years down the road, right? I'm doing it now instead of high cap because I don't want to change it out in 3 years. I'm doing it now because I know I'm going to need it because my use case is going to continue to expand. There's various reasons for it. And frankly, there's a lot of OEMs that have got such a high demand for 5G from what I call the hype, where their end customers are just saying, I want this. They're building it. So then to some degree, it's you have to have it in your portfolio type of thing. But if you look at overall sales, LTE still, is dominant, and 5G's curve is, starting to move up. And as the delta between LTE high cat and the low end of 5G come closer together, I think that'll start to accelerate. Red cap will obviously really start to accelerate it. And then when we get into future releases and the market starts to settle and all the banding reallocation gets done, boom, that's when you'll see the mass move from LTE. But we're talking the end of the decade time frame.
Yeah, and it makes sense for people to be early adopters, I think. If you can be an early adopter of 5G, you probably should for all the reasons that Jeff had listed. And it really just comes down to your BOM tolerance for your cost. Again, your longevity for your product life cycle, how mature the technology is right now versus what it's going to get. 5G will outperform LTE and uplink, not currently, but as we go down the road and the spectrum allocations get made, then 5G is going to outperform LTE in many different ways, not only in FR2 but also in FR1 as well. You have capacity for higher bandwidth channels, up to 100 megahertz channels, which is going to really increase your throughput. And so it's a good place to be if you can get there, and it's a good thing to be an early adopter for that technology, even if it might cost you a little bit more. In the long run, it's going to save you, and it'll save you time, both and money in the long run, I believe.
Yeah, and Amanda, just to kind of add on to that, we've had some customers do what I'm going to call proof of concept, where they're getting their learning curve, right? Their engineers are getting their feet wet and learning what they need to learn. but they've not moved forward with a commercial product. So they haven't gone through the certification process. And standalone support for private network hasn't matured as much as a lot of people expected. I think with the new generation of chipsets, we'll start to see maybe a little more ramp up in the private network. So folks are getting their feet wet now with the current modules, knowing that when the new ones come out later, early 2023, they can jump in, with all that experience because like from a firmware perspective, and Tim, you can address this better than I can, but from a firmware difference, going from the first generation to the second, your learning curve is going to be pretty small, I would think.
Yeah, absolutely. Another thing I've seen is some of the folks are doing proof of concept. A lot of those folks are using private networks right now, and primarily on private networks, I'm seeing a lot of SA deployment. So it's a lot of standalone networking is done on private networks. It hasn't really been adopted largely by the MNO networks, but private networking SCA is a big thing, and that's what a lot of folks are experimenting with right now in 5G.
Tim, one thing you could probably address real quick on the firmware deltas between the current 5G versus the next is there anything really unique that they're going to have to think about from a standpoint of the firmware going to SA mode only, or, is there, I know most our firmware uses mostly AT commands, but there are other options too. So especially when you get into PCIe, so maybe you can kind of just address that a little bit.
Well, our HiCat modules, they all support, our HiCat 5G modules all support PCIe and also USB as well. A lot of customers are utilizing QMI commands, which is basically a Qualcomm-based command structure that kind of emulate the AT commands, but it uses a different structure. So if you're designing a host with a Linux type of background, then QMI is a good way to go. It's an efficient programming language, and it's pretty familiar with a lot of developers. And so as the firmware changes, the QMI commands will expand, and you'll have greater capabilities as far as controlling the module.
Yep.
So maybe another interesting point that we should cover is what an OEM with an existing cellular LTE design needs to consider. Is there some sort of unique process for a design based on LTE?
Yeah, I think we kind of touched base a little bit earlier in the conversation on this. The bottom line is start over to some degree. Obviously you've got your design that's existing and you have your use case defined. You probably have your software layer well thought through. But then from there, this is where Tim and his fellow peers in the 5G space pull their hair out, because for as many of the different types of designs out there and their use cases, it's just amazing how many gotchas there are when it comes to doing LTE to 5G.
And primarily that has to do with a Linux-based host. You have to make sure that you're using the latest kernel in your host. We've had multiple customers that are trying to adopt an older kernel and an older host, and that worked fine for controlling, the older modules in the early LTE devices, but it's just not mature enough to have all the commands that are available for the 5G devices. And so what we find ourselves doing is having to try to backport some of these kernels, and it's just a lot of work, and for us and also for the customers. And it's better if you start from a fresh design. You can use a lot of best practices, of course, from LTE designs, but you have to make sure that all your firmware and your kernels and your hosts and your programming has been brought up to date to the latest standards, and that's going to make it go a lot smoother for you.
I think the other thing, if you look at LTE versus 5G FR1 versus FR2, which is millimeter wave, the big awakening has been, I don't know how many customers have said, hey, my LTE design's a 2-antenna design. Can I just use that for 5G? Well, no. To get the value of 5G, you need 4 antennas. And when you go to millimeter wave, you need the 4 millimeter wave antennas to give you diversity of direction, so line of sight, if you remember correctly. And then you have to have the 5G paddle antennas for the FR1. So that's 8 antennas, and trying to squeeze that into a small form factor is literally impossible. And we've had a lot of folks try to do that. And they found that to be, very onerous into almost impossible. And I think that, the big thing is if you don't have the right kernel, and let's say we backport our drivers to support that, you lose feature functionality. So why are you making that investment to basically just stay status quo? Because on the hardware side and the software side, if you can't update your host and the drivers and the kernels and all that good stuff, you just got a dead box there. You spent a lot of money on as we go forward. So if you really want to future-proof, you got to be thinking about all this stuff and take it into consideration.
Right. Yeah, antennas and antenna real estate, yeah, those are all things to consider in your new designs. Yes, you do have to use all 4 antennas if you want to take advantage of MIMO. Quite often you've got Wi-Fi residing in the same box, which is also going to have antennas for Wi-Fi as well. So you need to make your device large enough in order to handle all that real estate. And that's always a big compromise when you're designing antenna systems between size, antenna efficiency, spacing. You have to calculate what you're willing to give up in order for performance and size. So those are all things that you have to consider, especially with the new 5G design.
Mm-hmm. Yeah. So let's shift gears a little bit and maybe discuss some use cases. Jeff, you talked about cameras and video streaming. What other applications would most benefit from 5G? And we can talk through a couple examples here.
Sure. IT infrastructure fallback is a good one. That's what a lot of folks are using it for your LAN and WAN fallback on your IT infrastructures. Now especially take advantage of the high data throughput. When you have an edge router or system that you want to future-proof and you want to basically be able to mitigate any downtime, that's where 5G can come in handy for you.
Yeah, we've seen most of the early designs are around what I'm calling the router gateway space, as Tim pointed out, right? So that high-end CPE routing and gateway kind of capabilities, and you're seeing that a lot of the SD-WAN providers that either build their own or outsource their hardware are making that transition as well. Some of this is because that's what the market's demanding, and some of it's future-proofing, so it's a little bit of both. But, to date, that's where we've seen the bulk of the 5G interest. Now, you've also got robotics, where you need, you probably have artificial intelligence software and you need high throughput. There's some healthcare examples where you're doing imaging and things like that. Most of it is still trial and error because everyone's trying to decide whether wireless for those scenarios makes the most sense. And so there's a lot of cutting your teeth on that kind of concept. But we have seen some robotics, whether it be primarily, I guess I would say factory driven, some remote, some of the big delivery operators are working on those little robots that run and deliver packages. They're starting to play with 5G there. But I think, when we get RedCap, you'll start to see that really change. You'll see the market opportunities open up, while the same thing will happen in the low end of routers, gateways, and CPE equipment. You'll start to see those who don't need necessarily all the throughput, but they need more uplink, and the price point makes sense. So they'll and that can be a camera or video. I mean, Cat4 does really well for most video applications. So the transition will be pretty natural for security cameras. We're seeing actually broadcasters that are doing 5G solutions because they're trying to do more high definition type of video uplinks. We've seen the drone industry starting to look at 5G. Still trial and error. We'll see how 5G and drones are compatibly functioning. And then in the private network space, manufacturing. If you're looking at building out a factory or automating a factory, 5G can provide an easy drop-in network concept. And when I want to caveat that that's primarily going to be on the aggregation side. It's not necessarily going to be at this point every single endpoint because of the pricing of 5G right now. But someday down the road, as more of the low end of LTE starts to get adopted into 5G, that'll change. But for right now, most all your applications are really high throughput and really focused on the uplink side. People that are transmitting data back to a host environment or back to the cloud. That's kind of my take on it, Tim.
I don't have much to add to that outside of the factory analogy. Because you might ask yourself, well, you've got Wi-Fi available. How come these folks aren't using Wi-Fi? And what they're finding is just, the distance and the reliability that they get on Wi-Fi is not as good as you can get on a private 5G network. And so a lot of these manufacturers that are doing mission critical type of applications that need that reliability, that need that throughput, are starting to look at private 5G SA networks.
Yep, absolutely.
Yeah, maybe we can kind of wrap up here by just briefly talking about Telit's 5G products and what we can do to help customers.
Sure. So, we've been leading the way in 5G modules, where we're taking the Qualcomm chipsets and building modems that can be integrated into an end device. So we started out with the XDX55 based modules, which supported both FR1 and FR2. And those are now in production, have been for over a year, and have been put into several designs and are in mass production with end products. The newest generation, the SDX 62 and 65, is where Qualcomm has basically added the SA mode fully available for all the different bands that everyone's looking for, especially for CBRS and private network. And we'll have those modules out at the first of the year. And then as we move towards the end of 2023, early 2024, we'll have the first engineering samples of RedCap, and then there'll be release 18, which is the 72, 75. So there's these, phased in evolution as we talked about at the beginning. And from a Telit perspective, we provide engineering support through the team Tim works on, right? We've got dedicated engineers that do nothing but 5G and HiCat, and they're very well versed, as you can see from Tim's comments, on what they've seen and what's going to happen as we move forward. And I think they can also be a big support in answering a lot of those questions before you really dive into the design. And then we also offer design services in the sense of design reviews. We don't actually do end product designs. We have a design review process where you can send us your Gerbers and schematics, and we'll send that in, and the engineers will look for the obvious things. And I think Tim and his team have got really good experience where if someone has a question about, this is the host I have, what do you think? They can pretty quickly off the top of their head say, you better do something about that, or you're just fine. And then recently we acquired MobileLogix, and so now we have the capability of end-to-end design. So that's kind of a value-add service if someone wants to go down that path. But all of that is focused around our entire portfolio, but we do have specialized teams. Even our R&D is split so that we have dedicated folks to 5G, so we can provide the best service, especially in what's really a complex and ever-changing environment. Day to day, it's like new changes, new features, new functionality, new firmwares, new certification processes, new products being released. It's a wild ride.
Yeah.
All right, guys. I think that kind of wraps us up. Any last comments here?
I'm good. Tim?
Yeah, I'm good too. It's just, I've been in this industry a long time, and I've worked for carriers, I've worked for manufacturers, I've worked for the test equipment side, for the infrastructure side. This is an exciting time with 5G launching and these changes coming, and it definitely keeps us busy, keeps us sharp, and I think Telit's well positioned to be a big part of this next generation of high throughput IoT devices.
Yeah.
Super.
Well, guys, appreciate it so much. Audience, thank you so much for joining us today. If you need some additional information, please be sure to check out the resources section. And we're here, right? We're happy to help. So reach out, request a consultation. We'll get you in touch with the right people. So thanks so much for joining us today. Thanks, Jeff, Tim.
Thank you, Tim. Thanks, Amanda.
All right. Bye, Jeff.
Bye-bye.
Bye.